Alright, welcome to this lesson with me, Teacher Kamanga. In our today's lesson, we're going to look at the topic moment. Now, we're going to revise this topic with a question that has been extracted from a past paper, Science Paper 1, 2018 GCE, question number 4. Alright, so the question reads, figure 4.1 shows a crane lifting a brick from the building of a house. The weight of the brick produces a turning effect of moment on the arm of the crane about the point P. So the point P is this one. We're looking at this point. This is where the turning effect is taking place. The weight of the brick is 12,000 newtons. Okay, so we have a brick here which is 12,000 newtons. Okay, now remember, this is where the turning effect is taking place. So this is going to be our pivot in this question. Then we have a distance from there up to there, which is have been given to be a 20 meters. Then there's a force which has been applied, which is a brick which is being lifted, which is about 12,000. All right. So now the question is saying, calculate the moment of this force using the distance moved on the figure 4.1. Okay, calculate the moment. So remember, we said the moment is defined as the product of the force and the perpendicular distance. Okay, so there is that perpendicular distance that we're talking about, of which this is what is happening here. Okay, now that also definition give us the formula like we said last time in our last discussion. So we're saying moment is equals to the product of the force times the perpendicular distance, like that. So meaning that in this case we just need to multiply the force that we've been given, which is 12,000, times the distance that we've been given, which is 20. Okay, so we just need to multiply. So we say 12,000 newtons times 20 meters. Okay, so 12,000 newtons times 20 meters, we are going to arrive at when you do the calculation, you're going to have 24,000. Okay, so we're going to have 240,000. Okay, so this 240,000 to be Newton meters. That is going to be our moment in this case. So remember, the most important thing that we need to know, we need to locate the pivot where it is, of which we've located the distance, the perpendicular distance to the force, which is the one that we've been given. So we just multiply distance times force to arrive at this answer. So we have about 240,000. Okay, so the 240,000, that is our moment. So 240, okay, Newton meter. That is the first question. All right, the first answer. So let's come to the second one. So the second one is saying, calculate the useful work done by the crane in the lifting of the 12,000 newtons load through a height of 15 meters. Okay, so here we're talking about work done. Okay, we're talking about work done, and by definition, work done, we're saying it is the product of the force and the distance moved in the direction of the force. So we're able to see the difference between the moment and also the work done. The work done, the distance should be moved in the direction of the force. Okay, we need to understand that. So that justifies what work done is. So in this case, the distance we've been given, which is the 15, and the mass we have, which is the 12,000. So we're just going to multiply 15 times 12,000. Okay, 15 times 12,000. So in doing our calculations, okay, let's try to do our calculations in this manner. I'm trying to locate the calculator. Okay, so we have 12,000 times 15 meters, so we have about 180,000. Okay, so our answer here, it is going to be 180,000 joules. Okay, so work done is measured in joules. Remember, work done, we have said work done is equals to the force times distance. Okay, so our justification is that the product of the force times the distance, which is along the line of action of the force. So if the force has been applied in this direction, the distance also must be able to be in that direction. So if this is an object, applied this force, this object should be able to move in that direction. Then there is a force, there is a work done to this particular object. This is why we're saying it is a product of the force and the distance moved along the line of action of the force. So this is our justification. So this is how this question was supposed to be answered. Okay, so this has been Teacher Kamanga with you. Have a lovely day.